Okay, 4.2b. Let's continue with this problem we started. Didn't really do anything with it. And let's try to combine some things together so that we can get this y isolated. So, y plus 4 minus 6. I'm going to assume you remember how to do that. Negative 2 or minus 2. 7 minus 1 is 6. Alright, so now it's broken down or simplified into just 3 different terms here. So if you remember on that last problem, we have a minus 2. In order to get rid of that minus 2, we said we had to add 2. Actually, if you notice, we're just doing the opposite of what we started with. If it says minus 2, we're going to add 2. Later on, if we have a plus 2, we're going to subtract 2. Whatever we need to do to combine those to make 0, that's what we're looking for. So negative 2 or minus 2 plus 2 is 0. And remember, we have to do the same thing over here. So y then, because those are gone, equals 8. So let's try it up here. If we have 8 plus 4 minus 6, does that equal 7 minus 1, which is 6? So 8 plus 4 is 12. 12 minus 6, yes, is 6. So we did it right. Let's continue on with a couple more examples here. Let's try 3x minus 2 minus 2x equals 4 minus 9. Now this is some of the stuff that we had done in the past. Combining some things. You remember what we did with like terms? If we have an x and an x with a number in front, we can combine those two. So we have 3x minus 2x is x. We have 3 of something minus 2 of something. We have 1 of something left. And let's just leave the minus 2 alone for right now. 4 minus 9 is negative 5. So, what do we have to add to this side in order to turn this minus 2 into 0? Plus 2. And we have to add 2 over here. So those disappear. And negative 5 plus 2 is negative 3. So there's my solution set. You can plug it in and try it if you like. Seems like all my markers are going dry today. Okay, so let's continue on a little bit. Let's take a negative 3 minus 6 equals x plus 4. This is example number 7, still on page 271. Alrighty, let's combine like terms. Negative 3 minus 6 is negative 9. Negative 3 plus negative 6, if that helps. Negative 9 equals x plus 7. The only thing strange about this is my x is on the right-hand side. Doesn't matter. If you don't like the x being on the right-hand side, some people don't, take everything here, move it over here, and put the x here, or the equal sign here. So you could rewrite this as x plus 7 equals negative 9. Doesn't really matter. They're the same thing. We just put this stuff over here and this stuff over here. So if you like the x on the left, feel free to do that. Alright, so now we have a plus 7. 7 is added to our x. In order to get rid of that plus 7, we take 7 away. But remember, we have to do it to the other side. Negative 9 minus 7 gives us negative 9 minus 7, I'm not thinking straight today, equals x. So our answer is x equals negative 16. If I did this right, let me see what we've got here. Negative 3, yeah. Okay, so I guess I didn't do example 7. I kind of made up my own because this was supposed to be a 4. That's okay. X equals negative 6 in that made-up problem I just did. Okay, let's continue on. A couple examples here. Let's do page 272, example 9. 4 times 2a minus 3 and minus 7a, and let's make that equal to 2 minus 5. Alright, not as scary as it looks. Starts out looking a little overwhelming, but we'll just use the information that we've learned so far and continue on. Can we do anything in the parentheses? No, because I have 2 terms that are not like. I have a variable here and not a variable here, so I can't combine those. If you remember then, my next step is distribution. So I get 8a minus 12, and I'll leave my minus 7a alone for right now. Okay. Now I start combining the things that I have that are alike. Notice again how I circled the sign as well as the number. 8a minus 7a is a. Minus 12, we'll leave that alone, equals 2 minus 5 is negative 3. Okay, so now I'm down to real simple again, 3 different terms. So in order to get rid of this negative 12, I add 12 to this side, I add 12 to this side, which gives me a equals, because those disappear, negative 3 plus 12 equals 9. And that's it. So let's just go ahead and do a few problems. Page number 273, problem set 4.2. The first 10 problems there are just asking you to take the number after the semicolon and plug it in for x to see if it's a true statement. Numbers 11 through 26 are real simple ones that we just did up on the whiteboard. We get into 27 to 38. They're getting a little more complicated, but nothing that we haven't already done. So let's go down to 39 to 46 and look at a few of those real quick. Let's take number 40, which is 5 times x plus 1 minus 4x equals 2. Alright, so again we look in the parentheses, we do that first according to PEMDAS. X plus 1, we can't combine those, so we use our distribution. Combine like terms here, which happen to be these. We get 1x plus 5 equals 2 plus 5, so we're going to subtract 5 from both sides, and we get x equals negative 3. So hope that wasn't too fast, but we've done a lot of this before, so I don't want to go over and keep going over and over and over. But let's look at number 46, and then I'll stop. The reason I want to look at that is the negative sign in front of the parenthesis there. When there is a negative sign in front of the parenthesis, basically what that means is there's a negative 1 out there. But if you remember, most of the time we just don't show a 1. It's just like the letter X. Well, there's 1. I don't have to tell you how many there are. So instead of writing 1x, I just write x. It's the same thing with in front of the parenthesis here. If we just have a negative, we assume that there's a 1 there. So what we're going to do is we're going to distribute that negative to the parentheses. So let's put a negative 1 here just to make it easier. Negative 1 times x is negative x. Or negative 1x. Let's just leave that negative 1 there. Negative 1 times negative 7 is a positive 7 plus 2x equals, minus 8 equals 4. Combine our like terms. Remember, I circled made a box around the plus sign and the negative. Negative 1x plus 2x is x plus 7 minus 8 equals 4. X minus 1 equals 4. I add 1 to both sides, and I get x equals 5. So, there you go. The lesson and some examples from the problem set 4.2, and you're ready to go.